Good evening and welcome to my discussion on a MapReduce enabled scientific workflow composition framework. So the main aspect of the paper is a need for a MapReduce enabled workflows. And they discussed several different versions of these workflows and constructs and how we can implement MapReduce to better suit our needs. So let's talk about the main contributions. The purpose of a data workflow-based scientific workflow model that separates the declaration of workflow interface from the definition of its functional body. Then introduce a set of data flow constructs into the model to enable MapReduce style scientific workflows. And finally, realize the proposed model in XML-based scientific workflow specification language called WSL. So what is the scientific workflow model? Well, typically it has two layers, a logical layer which contains the workflow interface that models the input ports and output ports, and then a physical layer which contains the workflow body that models the structure and constituent components of a data flow. Constituent components can be a single task, single workflow, or a set of workflows. An extensive workflow model. So here we have a picture of a few different workflow constructs, and we're going to get into each of them in detail, but here's a little bit of how they work and what they might look like. So in our first one here we have the workflow model. In Section B, we have a single task-based workflow. Section C, we have a graph-based workflow. In Section D, we have a unary construct-based workflow. So a single task-based workflow, T2W, constructs essentially performs the mapping between an input and an output port of a workflow and the input-output ports of its constituent task. And we'll get into some more detail and show you how these actually work a little bit later in the slides. A graph-based workflow, a set of workflows that can be connected via their ports through data channels, communicate with others by passing data through data channels. And a G2W performs mapping between the input-output ports of a workflow and the input-output ports of the workflow and its constituents workflow graph, and thus exposes some of the I/O ports to the target workflow. Unary construct-based workflows can be seen as mapping from workflows to workflows. Unary constructs are very useful to enhance the capability of an existing workflow without coding efforts and to promote the reuse of existing workflows in various contexts. Essentially performs the mapping between the input-output ports of a workflow and the I/O ports of its constituent workflow. It carries out the semantics that is defined for the unary construct during the runtime map port of the construct. And then we have a scientific workflow construct and its composition. So we'll look here. The unary constructs can be applied to many different input-output ports, and the examples are listed below: the map construct, the reduce construct, conditional construct, and the loop construct. And we'll take a look at all of those and how they fit into our discussion. In the map construct, enabling the parallel processing of data products based on the workflow that can only process a single data product. It can have n inputs and one output. WA is designed as the map port, which takes a list of data products that need to be processed in parallel. And below we have a picture of how this workflow map construct would work. With the input of 1, 2, 3, 6, and 4, 7, you can see here that we would multiply those out by mapping them out. So 1 times 2, 3 times 6, and 4 times 7, and end up with the output of 2, 18, and 28. The reduce construct. Reduce construct enables an aggregation of the list of data products to a single data product based on a workflow that aggregates. And so again below, with the input of 359, you can see with starting at 0 and adding in the 3, we get the output of 3, and then we bring in the 5, getting an output of 8, bring in the 9, getting an output of 17. Conditional construct. Enables the conditional execution of a workflow based on a condition on one of the inputs. The user predicate P is set on the conditional port. WA can only be executed if P is evaluated to be true. This is typically looked at as a traditional if then else statement. And so you can see at the bottom predicate P, and we have a fail on the conditional port. The loop construct enables the cyclic execution of a workflow based on a predicate over the output of a workflow. The output of a workflow will be repetitively returned to an input port until P evaluates as true. We have a picture of this below with a set of inputs where O1 and O2 P evaluates as false, so we return back, and then finally you can see when we get to OM the inputs and P evaluates as true. So how do they tie all this together into something that we can use in the case study? So there's three big characteristics of the author's model. Workflows are the only operand in the workflow composition for the workflow composition, while single task based workflows are constructed directly from a task using the T2W constructs. All others are created as the composition of existing workflows. Every workflow can be directly used for workflow compositions through workflow constructs, and every composition results in a workflow, either a graph-based or a unary construct. And then workflow constructs are fully composable, and a set of workflows is closed under all the workflow constructs. So let's talk a little bit about the case study. The authors talked about the mating habits or a nuptial dance of a particular marine worm, and this is how they put it to use. So essentially in the first picture we have a simulation workflow where it has a set of parameters. Simulation parameters is SP, and the N, which is the copy or the the N is the number of inputs. And from there we can see the repeat construct, which will go through and construct an output list of how many successful matings. And then from there we have the SSWS, which is the single simulation web service, a single task-based workflow created from a task of web service that can run a single simulation and generate a Boolean result of the matings. And then we have a reduce construct where we'll combine and aggregate all the successful matings. And then in the analysis workflow, we have the simulation workflow actually implanted into the entire workflow here, but the starting points are the ALG, the angle list generator, and the CLG, which is the concentration list generator, which allows the user to set testing parameters, which is the T2W, and then we have a Cartesian join, which looks at every possible existence that we could possibly have. And then we move bringing in the N in the simulation of the mapping construct, and then we have the reduce construct where we add up all the results and have the output. Thank you so much for listening to my conversation tonight. And real quick, as one of the goals of the paper was to talk about the XML based text, I wanted to quickly run through and show the XML workflow language, or WSLs, where they show the specification example of a workflow interface, the WSL specification example of the workflow body for a graph-based workflow. We also had the single task-based workflow and the unary construct-based workflow. Thank you.